Hello, I'm KSteinacker, and we're going to be talking today in KI video number 5 about the receiving end circuitry of the cell phone. And we're going to just jump. In this knowledge integration, we're looking again at the whole top-level block diagram for the cell phone circuitry, focusing on the receiver end. We've talked in the last KI about transmitting a signal. Previously, we talked about power supply management and all these filters for data storage and processing all the data. But now we're going to be talking about receiving, incoming. In any of these instances, we have incoming signals, and they're going to be processed by the antenna. And we're going to talk about that regards to concepts learned in ECE 342. And then here in the RF front end, we have a bandpass filter, low noise amplifier, mixer, a local oscillator. And we're talking about that with concepts from both ECE 312 and 332. And then finally, in the baseband back end, another amplifier and low pass filter to get our signal ready for going into storage or being transferred into recognizable audio or video. We can now begin a brief discussion of the receiving antenna. And this is a figure given out during our KI showing a PCB design for an antenna. This isn't necessarily for a cell phone, but this is just what we're going to be going over. This is a three-dimensional design, so we have the top layer, as mentioned here, bottom layer. So the whole of all of this architecture here is actually antenna as well, and it's a three-dimensional design that goes down in this bottom layer, and so it kind of curls around here, and that generates a larger overall electric length. And keeping in mind that there is in between this 1 millimeter thick layer is this filler stuff, which is the PMMA dielectric. You see that there's a single-ended input of 50 ohms, so it's like the basic impedance of the whole circuitry down here. And so we have this matching network set up. Match the impedance must be matched between the antenna structure and front end circuitry here. So we have a matching network that matches the impedance for max power flow. And that's about all we have to say about the receiving. Now that we've started to understand how the incoming signals are received onto a receiving antenna, let's talk about an example where we have several different antennas, and these are all amplitude modulation just for the sake of simplicity. We're representing different frequencies for different applications. That is Bluetooth, GSM phone, radio, and wireless. And say we want to receive a phone call, so we're going to try and get only this band. So these are all coming in, and they're all added together. So all of these signals are all added, and they go here, and that represents this, where you have all of the different frequencies being represented in this one figure. Now the purpose of this bandpass filter is to filter out just around where we want our GSM phone. So it's going to filter around here, and that's why at this point we only have omega naught, and that's what we get on the other side of our bandpass filter. That's going to go through a low noise amplifier just to get it ready for the mixer. We're going to talk a little bit more about the concepts, both of how to build this filter and how this low noise amplifier works in later section focusing on ECE 332. But now we're just talking about the signal processing. So it's going to be multiplied by a carrier signal for GSM phone band here. So it's going to be the same as that. And it's so it can be multiplied and get us to our baseband appropriately. Waveform here. It's going to be on the other side of that. So you can see you're going to get copies. You're going to get one copy at baseband, and then you're going to get also another copy at 2 omega naught. It's going to be amplified again, and you're going to go through a low pass filter. The low pass filter would just make it so we only get the baseband. And this effectively decodes our signal. So we have our baseband, and this is the original information that we've decoded, ready to go into either signal for a speaker so you can hear the phone call, or into data storage. Having previously discussed the signal flow from the input to output of this whole system with the receiving end of the cell phone, we can now talk about just a basic design that we talked about in our pre-work. And if we can set up the parameters just so of a filter to make it pass only the frequency that we want. The low-noise amplifier is going to set up the signal, give it more gain to go into the mixing. The mixer, we talked about the mixer in KI4, but we can talk about the low-noise amplifier in a small way here. For overview, we know that having a PMOS will give us a lower noise benefit, and we know that if we increase our VSAT, it will also have our benefit, so we can drive our VT up in our transistor, and we know that PMOS transistors have a higher VT. Next, we can talk about this baseband amplifier. This is just a kind of a standard amplifier. It's a telescopic, non-folded cascode amplifier. We may not have to have something as large as this, and we may not need to have that high of gain, but this is an example of a baseband amplifier. And then low-pass filter. And it presents a low-pass filter based on our parameters we have here. And only allow that baseband signal to pass through. I hope this video was clear and informative, and I'll see you next time for knowledge.